Physics is comfortable measuring the universe as a collection of isolated points. But to find the geometric constraints that govern these points, we have to look past the individual particles and examine the continuous process connecting them. Our current map of the subatomic world is the Standard Model. It organizes the universe into exactly 17 fundamental building blocks, categorized as quarks, leptons, and bosons. Verifying these 17 particles required constructing the Large Hadron Collider, a 27-kilometer ring designed to smash matter apart at nearly the speed of light to capture its components. In 2012, the detection of the Higgs boson finalized the model. For the first time, all 17 predicted entities were confirmed to exist. However, that count is a choice of notation. The Standard Model groups 8 distinct channels of gluons into a single category. It ignores antimatter in the primary count and labels the positive and negative W bosons as a single type. When we assign each of these their own separate roles, the count changes. The observer-dependent theory of everything, or ODTOE, removes these grouping conventions. By tracking every distinct interaction, it identifies 22 hidden roles, bringing the total to 39. This framework replaces particles as solid dots with the concept of stable geometric configurations. Every physical event is modeled as a triadic loop consisting of 3 nodes: the observer, the operator performing the measurement, and the observed result. This loop is not a flat triangle. It exists topologically on the surface of a torus, a donut shape. The way the loop wraps around this surface determines the properties of the matter it describes. For a fermion, such as an electron, the loop must travel twice around the torus's minor axis before it can close. This double circuit is the geometric cause of spin 1/2, where a particle must rotate 720 degrees to return to its original state. Because particles are pathways on this geometry, the laws of physics are not a list of separate rules, but the inevitable results of how a loop interacts with the torus. We begin our map at the scale of the atom. In this framework, our current window of observation is recursion level d equals 0. The triadic loop contains 3 joints where the observer, operator, and observed nodes intersect. These 3 joints generate the 3 known generations of matter, with each generation being a heavier version of the last. The operator node at this scale is a network of 8 channels connecting these joints. This is derived from the square of the 3 joints minus the 1 redundant state. The 3 direct channels in this network represent the known leptons, the electron, the muon, and the tau. The 3 reverse channels represent the positron, the anti-muon, and the anti-tau. In this geometry, antimatter is not a mirror image, but a distinct functional role carrying information in the opposite direction. This leaves 2 diagonal pathways, labeled L7 and L8. These are neutral states with no charge and no equivalent in the Standard Model. These diagonal roles are heavy neutral leptons, or HNLs. They are particles with neutral charge and spin 1/2 that are the predicted source of the mini-boon and X17 anomalies observed in recent accelerator data. This loop is actually a spiral. Because the path around the torus is slightly offset, the loop fails to close perfectly on itself. This leaves a physical gap in the geometry, labeled as delta psi. Mathematically, the width of this gap is determined by the difference between the irrational path of pi and the integer nodes of the loop. This gap manifests as 3 separate projections. These are the 3 generations of neutrinos. This explains why neutrinos have almost 0 mass and exhibit only left-handed chirality, or spin orientation. They are not solid particles, but the specific geometric remainder of the spiral itself. If we step inside the atomic observer node, we find a smaller version of the same structure. This subnucleonic level is recursion level d-1. We first observed the structure inside the proton here at the Stanford Linear Accelerator. By firing high-energy electrons at protons, researchers proved they were not solid, but contained smaller entities called quarks. At this scale, the triadic loop generates the 6 flavors of quarks. The up, charm, and top quarks occupy the observed node, while the down, strange, and bottom quarks act as the observer. The strong force binding these quarks is the operator node. When expanded, it reveals the same 8-channel network, which here represents the 8 distinct gluons. This shows that quarks and protons are not different types of matter. They are the same geometric roles repeating at a smaller, recursive scale. To maintain a unified system, the atomic and nucleonic levels must communicate. This requires specific bridges. The W and Z bosons are these bridges. They allow the system to transmute roles and verify that the nested loops remain synchronized. There are also two entities that exist across all levels. The photon acts as the geometric link between different tori, and the Higgs field provides the baseline potentiality that defines mass for every role in the hierarchy. The total count is now visible: 17 roles at the atomic level and 17 identical roles at the nucleonic level. Add the 3 bridges and the 2 trans-level entities, and we reach 39. These 39 roles provide a complete map of subatomic interactions, replacing the 17-particle standard model with a closed geometric system. The strength of a geometric theory is its ability to predict physical constants without using human-measured values as a starting point. In a recursive system, the scale between levels is determined by the golden ratio, phi, roughly 1.618. This constant ensures that the nested tori can occupy the same space without disrupting each other's stability. We use this scaling to derive the mass of a proton relative to an electron. The number 6 represents the 6 possible permutations of the joints in the loop, while the 5 powers of pi represent the 5 recursive layers of spirality. The result is 1836.12. This geometric calculation matches the accepted experimental value for the proton-to-electron mass ratio to within 0.002%. This suggests that the mass of a particle is not a random number we have to find in a lab, but a direct consequence of the golden ratio and pi. If the pattern scales down into quarks, it must also scale up into the macroscopic universe, creating levels D+1 and beyond. The framework divides a torus into 3 energy sectors. The large radius represents dark energy, the minor radius represents dark matter, and the spiral gap represents baryonic matter. The ratio between these 3 sectors, phi squared, 1, and z, matches the proportions found in the cosmic microwave background by the Planck satellite. This geometric model aligns with our cosmological data to within 1.2 sigma. This theory is strictly falsifiable. If the Large Hadron Collider finds a true 4th generation of matter, or if neutrinos are proven to have absolutely zero mass, the spiral geometry would be mathematically impossible. The Standard Model has been our best description of the subatomic world, but it may be just one visible octave on a recursively scaled keyboard that extends infinitely in both directions.